So I want to just start by saying that, well, thank you, first of all, for having me here today. I have learned so much today about innovation and technology in rail. It's been a real eye-opener. I just want to go back one. Okay. As the last speaker of the day, I'm going to make this quite brief because I'm sure that you're all ready to go home. So my focus is on people rather than technology. And one of the things that we need to do is start to think about how people relate to the technology. So I want to start off by showing you this, because these types of, go back. What we're seeing here. Yeah, these types of incidents are all too common. And apparently, this happens, according to the Safety Task Force, about 20 times a year. I suspect that's the tip of the iceberg. I've not met a company yet that has actually told me that they record people losing situational awareness trackside. So, as far as I'm concerned, whilst 20 is a big enough number, I suspect reality is that it's even bigger. And the reason for this is because we are dealing with human beings. And human beings are fallible. So I just want to talk about that for a minute, because we are prone to making mistakes. We are prone to making poor decisions. We're sometimes dangerous. And we've even been known to do something stupid every now and again. And I want to, I can see one or two of you smiling like, yeah, I've done that. I want to just talk about that a minute, because it's really important that we understand why people make these mistakes. And actually, it's quite important that they understand why they make these mistakes. Okay, so I'm going to give you 3 common examples to illustrate this. So the first is alpha state, also known as daydreaming. And we need an accumulation of about 10 minutes in every hour, and it's about conserving energy, okay? 10 minutes in every hour, an accumulation can be taken the odd second here, the odd few minutes there. We need even more if we're tired, okay? Now, the problem with this is it's a natural human reaction, brain reaction. We can't stop it, okay? And we also don't know when it's happening. We just go into it, and we're only usually aware when we're snapped out of it. So you do know, don't you, that you've had 10 minutes in every hour while you've been in here. Yeah, so the problem with that is that if you think about trackside workers, for example, it means that they've lost conscious awareness for about an hour and 20 minutes every single shift. That's a scary thought, right? In an environment really where we should be alert as often as we possibly can. An accumulation of an hour and 20 minutes every shift, every worker, is scary. And that includes the cost, the pick, and the site warden. So the next one is availability heuristics. And this is a brain function that it regulates our threat response. And the way that works is that if you have seen recently an accident, an incident, or a close call, then that's readily stored and recalled so that you don't put yourself in that same situation again. The problem here is that if you have done the same thing hundreds of times and nothing bad's happened, then that part of the brain stands down. It can't be on alert all the time, because actually that would take up too much brain function. So it stands down, and you will recognise this as complacency. And complacency in a dangerous environment is also scary, right? Another brain function that we naturally have to have is we need to connect and belong to communities. And so we naturally adapt to the situation and the people we're with. We look for patterns of behaviour on a subconscious level, and then we learn what's acceptable and what isn't acceptable, and then we conform. Now, the problem with this is that it means that bad habits and low standards can be passed from peer to peer without us even knowing about it. Another scary thought, right? So, I could talk more and more about human fallibility and all the things that our brain functions do that put us fairly risky. But in the interest of time, we'll move on, and I'll show you some of the mistakes we make as a result. So, when we start to get into work and we're focusing in, we lose our immediate environment. We're very unaware of what's going on around us. And I've seen people do things like step back to have a look at their work, or walk round the side of a pick to go and ask a question. And in these circumstances, they've been very unaware that they've put themselves outside of their safe zone. I also heard a guy the other day ask the question, why do we need these devices? I can see 4 miles up the track that way, and I can see 4 miles down the track that way. I'm safe because I can see a long way in either direction. What that tells me immediately, though, is because he thinks he's safe, his RAS has stood down, and now he's in more danger than he ever was before. Because once he starts focusing in on his work, he'll become very unaware. He won't be looking up or down the track. He's actually in more danger now than he would have been had he only been able to see half a mile up the track. We also see things like bad habits creeping in. I've seen firsthand people jumping over fences rather than walking half a mile to a safe egress gate, for example. And they do this without thinking. I've also seen people or heard of people accessing sites in the wrong place, inadvertently. And this is really disorientating, particularly at night when they can't orientate via furniture. So all of these things, these mistakes that are made by human beings, we need to start looking at how do we mitigate these types of things. People put marker boards in the wrong place, for example. All of this is human error that puts people at risk, and they're very unaware of it. So what do we do? Well, in an ideal world, we'd just have blockages every time people were trackside, but that's not going to happen. So what we do instead is we rely on the COS and the site warden and the PIC and people putting marker boards in the right place. But we can't rely on people. We've just said that. So we need to find some way of bridging that gap between human fallibility and their safety. And technology is the answer to this. Technology can provide that timely tap on the shoulder when a trackside worker loses situational awareness. And this is where geospatial technology comes in. So geospatial technology, I don't know if you've heard of it before, I'm sure you have, but I'm going to cover the basics here just in case. So geospatial technology is anything used to acquire, view, or store geographical data. The device that you have in your pocket and have had for probably the last 15 years or so is a great example of this. It can tell you exactly where you are using GPS and Google Maps. It can tell you where the nearest vegan restaurant is and how to get there on foot. So in its own way, it's actually providing you with situational awareness when you don't know where you are or which way to go. So it stands to reason then that we could use this same technology to keep people safe on sites when they lose situational awareness. However, there is a problem because geospatial technology, and in particular GPS, isn't that accurate. If you've ever been in your car and your sat-nav's been saying, turn right, turn right, turn right, and you think, I will turn right when I get to the junction, but I'm not there yet. And that's because it can be anything from 1 metre to 10 metres inaccurate. Now, the problem is, of course, that that's not good enough, because on a site, it would look like this. The GPS would be telling you you were here, where it was safe, when in actual fact, you'd be over there, where it's not safe. Now, fortunately, we have access to infrastructure that is a collection of established base stations that are camped around the world, and we use triangulation to accurately pinpoint where someone is. And I say accurate, it's within 14 to 16 millimetres accurate. Ooh, that's peaked one or two, hasn't it? It's highly accurate, okay? And if I'm being honest, the people that are using this, the guys and girls on the ground, they love how accurate it is. In fact, one guy said to me, he said, you know what, this keeps us safe within an inch of our lives. And I love that because it does. So, welcome to geofencing technology. Why is there a blank screen?
What is geofencing technology, and how can it help improve the safety of our track workers? For us, a geofence can provide a virtual barrier around planned, safe working limits. The technology detects when someone steps outside of the virtual barrier and alerts the wearer, providing an additional tap on the shoulder if they lose situational awareness. It comprises of two components: a simple dashboard used to set up a geofence zone around planned safe working limits, and a device worn by each worker. The device recognizes the precise location of the barrier so that each worker can be alerted if they stray too close to the edge of the safe working limits. The geofence barrier is set up during the planning process when agreeing the safe working limits. Network Rail's geospatial data provides precise locations for this step, which is carried out in advance of workers being deployed on track. On site, the safe system of work is implemented by the COS or PIC, and the warning device is used for secondary protection in addition to the site warden. The device is lightweight and designed so that tasks can be carried out unimpeded. It alerts the wearer through sound, light, and vibration alerts. The alert will continue while the worker is outside the virtual barrier, and they must return to the geofence safe working limits to reset the device. By harnessing the accuracy of geofencing technology, we can further improve the safety of our track workers' teams.
So what I should have said was, that's a video set up by Network Rail to show that we are aligning with their specifications. So to add to that, what you can see here is just how closely we can create a safe working area. Even on a long sweeping bend, we can use measurement tools to make sure that we are compliant to regulation away from the live track. We use things like a measurement ruler tool. We use what 3 words for access, for example. And what else do we use? What 3 words? Measurement tool. Oh yes, miles and chains overlay. That's what we use. Planners are finding that this is a really useful tool because actually they've had very limited amounts of measurement before, and because this is highly accurate, it just gives them that extra assurance that when they're doing their safe systems of work, they are able to measure out really accurately those safe working areas. And there's more, because we use high resolution imagery. It's Network Rail's imagery actually, and what this does is it gives planners an actual and virtual view of the site. Now the great thing about this is that we are using Network Rail's system. So rather than Google Maps, which is very often only refreshed every couple of years and is so high up that actually the images as you get lower become very fuzzy, this is done by drone and is updated really regularly and is very, very accurate. What it means then is that planners can actually see, for example, where there's extra vegetation. And we always say to the planner, there is an unsafe side of the geofence and a safe side of the geofence. And if you put the geofence on the safe side, a little bit further out, you can then take into account that vegetation if people have to walk around it. This system is incredibly easy to use. It's really agile. We don't need any infrastructure other than what's already available. So it works in 3 steps. So the planner plans out the safe working area, and that takes about 5 minutes. Then the guys and girls wear the devices on their arms, their chest. We use click fast, which is what the police use, so it's a really secure attachment. They wear that, it takes about 2 minutes to set up, and then they can carry on with their work knowing that that's improved their situational awareness whilst they're trackside. We also know that this technology has other use cases, and we want to make sure that your assets are also kept safe. So we can use our devices to place on protective equipment like marker boards. It means that we can orientate that marker board to exactly the right place, eliminating those issues of them being in the wrong place and putting people at risk. We can also tag plant. So we can then create a virtual barrier around plant, and then if it's breached, then the driver is alerted, again eliminating that problem between plant and people interface. And another use case is asset tagging. So we can put these devices on an asset so that at the end of a shift, if we've been working near a live line, we can remove that asset. It can all be accounted for at the end of the shift, so nothing is left behind, which I believe is a very common problem. I can see 1 or 2 of you nodding. Okay. So this solution doesn't just keep people safe and assets safe, but actually it improves performance and cost efficiencies as well. But I want to bring this back to the people side of things, because at the end of the day, what we're really here for is to keep people safe. And one of the ways that we do that is to make sure that people are engaged with the technology, because let's face it, if it's left on a shelf, it's no good to anybody. So what we do is, this is a typical way that safety initiatives are introduced. Very often, safety initiatives are given to the workforce with very little context and sometimes no content. They're very often told, here it is, get on with it. Now, the problem with that is they feel ill-prepared. They feel like they're under time pressure. They don't know what's expected of them. And that starts to disengage them. And once they start to be disengaged, the initiative fails. Now, the problem with that is that we have to improve safety. So we introduce another initiative. The problem here is that this stop-start of initiatives is very wearing on the human brain. So it leaves managers wondering, is this one going to land? Are my efforts going to come to fruition? And workers are left thinking, here we go again, another initiative. And this is why we get what's called initiative fatigue. So we know human nature. We take a slightly different approach. So we start early with, We start early with socializing our technology. What that means is that we give context. Everybody knows why the organisation is bringing in this technology and what it's meant to achieve, what the outcomes and expectations are for this technology. Then we do some plug-and-play workshops where people can voice their concerns, have a little go with the devices, but it's in a safe environment, and this gives them context. And the context is, we know what it does, we know how to use it, and so that builds a little bit of confidence in the technology. Once we've done that, it means that everybody's familiar with the technology before it even starts to be deployed. So, once it starts to be deployed, we also take a very slow-paced view of starting to be tendered-led, and then we incrementally hand over. We build competence first, because that's what people need to feel like they are comfortable with the product. Then we build confidence that it will work, and then we build trust that all the system together is what will keep someone safe. At that point, we hand over to the client and tendered step away. We do this at a pace that suits our clients, not at a, here you go, get on with it, okay? Because that does switch people off. So once they are comfortable and confident, then we find that a little bit of magic happens. Because people start to buy in. We've built trust with them. They understand the capability of the technology by this point. And so what they do is they'll start to look at how we can improve this for current operations. And even better, they start to suggest new features for future features. And that's brilliant, because it means that they're invested in the technology, they're invested in the safety, and that's engagement. And that is how we combine behavioural science and technology. We do the education, we have brilliant technology, and we engage people in using that technology. So just to do a recap of the key points. Human beings are fallible, and that's a fact. We have geospatial technology that is the solution. We have an approved network rail solution in our geofencing, which is highly accurate and reliable. And we make sure that people want to use this equipment because it's no good on a shelf. So just to finish, I love working for Tended. It's a small company, but they are on a mission to save lives using technology. And I can relate this a little bit to the janitor when he was asked, "What do you do for NASA?" And he replied, "I'm helping to put a man on the moon." I relate to this in this way. When people say to me, "What do you do for Tended?" I reply, "I'm helping to save the lives of trackside workers." Thank you.